In a fleeting moment of cosmic history, humanity has surpassed its ancestors by millions of times in intelligence. We've created artificial intelligence, understood matter at the atomic level, and launched devices beyond our solar system. Yet, when viewed through the lens of the Kardashev Scale, a measure of civilization based on its energy harnessing capabilities, humanity remains among the most foolish. So, if one day we reach the pinnacle, controlling earthquakes, harnessing tsunamis for power, or even terraforming entire planets in the solar system, what will remain when suffering and desire no longer exist? Would such an existence still be considered human? The Kardashev Scale and humanity's position. In 1964, Russian astronomer Nikolai Kardashev introduced a new metric for civilizations based on the amount of energy a planet could harness. This work significantly impacted the scientific community, establishing his reputation. Kardashev developed his theory from the hypothetical ability of extraterrestrials to transmit radio signals across the cosmos for communication. According to Kardashev, there are three types of cosmic civilizations. Type 1 controls all of its home planet's energy resources. Type 2 harnesses the total energy output of its star. Type 3 commands the entire energy resources of its galaxy. Despite seeming abstract, these ideas are gradually becoming reality. Photovoltaic cells already convert light into electricity, and the vision of collecting stellar energy using encompassing structures like a Dyson sphere was described by scientists such as K. O'Neill and Freeman Dyson decades ago. Later, astronomer Carl Sagan proposed using Arabic numerals instead of Roman numerals to classify civilization levels more precisely. He calculated Type 1 as equivalent to 1016 Wh, which is comparable to the total solar energy incident on Earth. From there, Type 2 and Type 3 were set at 1026 W and 1036 W, respectively, based on a base 10 logarithmic formula divided by 10. In 2015, humanity was classified as Type 0.72, with an estimated power consumption of about 1.7 times 1013 W. In 1800, we were only at 0.58. And by 1900, 0.61. This growth rate remains modest compared to long-term potential. If the 2015 global energy usage were evenly distributed, each person would use roughly 2,300 W, a negligible amount compared to the technological potential we're striving for. Humanity's energy evolution path. One of the significant values of the Kardashev Scale is its ability to visualize the energy roadmap for the near and distant future. If energy consumption consistently increases by 1% annually, Type I planetary status could be achieved in about 600 years, Type 2 stellar in approximately 3,000 years, and Type 3 galactic would require another 5,000 years. These are challenging figures, considering current physical limits. While we know that growth cannot continue indefinitely, due to constraints on living space, raw materials, and resources, history has shown humanity's creative capacity to be limitless. We don't yet know if we can overcome current limitations, but if another civilization exists out there, it would open a new chapter in human understanding, something observatories and telescopes strive daily to detect. Kardashev's hypothesis has since been expanded to 7 levels, broadening beyond just signal transmission technology to include other factors. Type 1, planetary mastery. Currently, humanity hasn't even reached the first level because we're only accessing and harnessing a small fraction of the energy our planet offers. Primarily fossil fuels like wood, coal, and oil, finite and environmentally harmful resources. If humanity reaches Type 1, we could completely control all forms of energy on Earth. Fossil fuels would become a thing of the past, fully replaced by renewables like wind, solar, and hydropower. Energy would become so abundant and accessible that electricity bills might cease to exist. Using energy would be as simple as the air we breathe daily. We could even intervene with the weather, bringing rain to drought-stricken areas or regenerating barren lands. The atmosphere would achieve carbon neutrality, ending global warming. Damage from natural disasters would drastically decline due to precise prediction of their timing and location. Furthermore, humans would be able to inhabit places once considered uninhabitable, such as under the ocean or in extreme climates. Life in a Type 1 society would be incredibly ideal, but paradoxically, this perfection might eventually lead to boredom. However, the increasingly severe impacts of climate change could hinder this, especially if the world doesn't act fast and decisively enough to mitigate them. Therefore, to reach the first level on the civilization scale, humanity needs a radical shift in its approach to energy, access, and application. Imagine if humans could fully harness sunlight, wind power, and all natural movements to operate the entire planet. This sounds like a distant dream, but it's slowly becoming reality thanks to technology companies like Hillcrest in Canada. They are leading a global transformation by pioneering disruptive clean energy solutions, from powering next-generation electric vehicles to redesigning grid models. Hillcrest is opening the door to an era of superior intelligence. A prime example is their ZVS inverter, a device that converts electrical current with almost absolute precision and efficiency. While solar panels generate direct current, most everyday devices operate on alternating current. This difference necessitates an intermediate conversion system, and this is where ZVS technology excels. This device minimizes energy loss, achieving up to 99.7% efficiency. As a result, electric vehicles can charge faster and travel further, while homes, offices, and data centers use clean resources without waste concerns. Type 2. Stellar energy. Harnessing what would happen if humanity continued to advance and became a Type 2 civilization. At that point, humans could fully harness the sun's energy and use it not only on Earth but throughout the entire solar system. This resource would enable us to travel to Mars, terraform the red planet, and even transform Neptune into a new habitat. If desired to reach Type 1, humanity must harness all existing energy forms on Earth. To advance to Type 2, we'd need to access the full power the sun radiates every second. To do this, we'd have to construct a colossal structure orbiting the central star of our planetary system. This structure is the Dyson Sphere, a system of satellites completely enclosing the sun to continuously collect its energy before laying the groundwork for such a cosmic marvel. Humanity needs to solve its immediate problems at home. Currently, we face numerous risks from all directions: climate change, warfare, pandemics, and drifting asteroids in space. Regarding celestial bodies, NASA is currently implementing the DART project, aiming to control the trajectories of new asteroids. In 2021, they launched a spacecraft to directly impact Dimorphos, a smaller moon orbiting Didymos, a much larger object. This impact will alter their orbital velocity, thus deflecting the asteroid's path sufficiently to steer clear of Earth, creating the first human-engineered meteor shower. If the DART project succeeds, it will be a stepping stone, helping humanity move closer to Type 1 and potentially beyond. Assuming we control solar energy, all threats from space could be instantly neutralized. If necessary, we could even shift Earth's orbit out of harm's way to avoid collisions, thanks to the Dyson Sphere. Adjusting the temperature of individual planets would become feasible by redirecting radiation streams. This technology would open a new chapter, terraforming other worlds and transforming them into secondary habitats for humanity. Space would no longer be a limit, but the next destination for those wishing to leave Earth. You could go snowboarding on Mars this weekend and watch the sunrise on Saturn next week. A Type 2 society would transform space travel from a privilege into a service as easy as booking a domestic flight. Currently, embarking on a space journey costs millions of dollars. But in the future, that expense would no longer be a barrier. The Dyson Sphere could also help regulate sunlight to cool Earth, leading to a cleaner climate and healthier human